Alright, hello everyone, this is Mr. Crozier. I'm going to go back over this worksheet that we did in class the other day. We have a function here, h of t is negative 6t squared plus 84t, which is the height of an object after t seconds. So if I graph this, here I have it typed in, and I'm going to graph it. And I'm graphing it over this window from 0 to 14, and from 0 to 300 seconds versus feet. And you can see it's the course of a ball that goes up and then down. And what we're asked to do is fill in this table right here, which is time 0 through 14. And we're going to start with the height. Well, the height of the ball is just running these numbers through this equation. So here's the equation, and we can table set, start a table at 0, make it count by ones. I'm going to do auto for the variable. And now I'm going to go to the second table, and there's my table values. And that's the height. And what you'll see is the values go up, and then they go back down. So they go up to this height right here of 7,290, and then they go down, and that's that point in the graph right there. Alright, and then what we're asked to do is find the derivative. Well, here's height, and the first derivative is power rule, 12t 84. And what we've done is found the derivative. And what that derivative is doing is telling us the slope of this line ahead, or right above it, the rate of change. So if I can get those values in there, I'm going to go ahead for y2, negative 12x plus 84. Note that the equation's with t, but we have to use x for our calculator. And now if I look at the table, here's the table of the values here. And that's now the speed here. We have position, and now we have, I shouldn't say speed, I should say velocity, because sometimes it's positive, sometimes it's negative, but now we have the velocities. At the start it's going up 84, then 72, and at this point right here at the vertex there's no velocity, there's no speed, and then it starts going negative. So it's positive, 0, negative in terms of velocity, and you can get those values right there. And then we take the last derivative, which is derivative here, which is just power rule again, multiply the 1, make it 0, negative 12, and again that's telling us the slope of the line right above it. Then that's what derivatives do, they tell us how things are changing, and this is the acceleration. So if you take a look at that, and I'm going to go ahead and type that equation in here, it's a really easy equation. Look at those accelerations, negative 12, and you should be able to see that if you look back. Everywhere we go down here, it's dropping by 12. The speed is dropping 12. That's what it's telling us here. Here the position is dropped, or going up 84, up 72, up 60, up 0, then down. So the position is going up, and the acceleration right here is telling how this changes. Again, that's what derivatives do. They tell how the equation is changing. Some questions to answer. H of 5, well that's that value right there. 270, that's the height of the ball after 5 seconds. H prime of 3, well that's right there. And that's the speed of the ball. The ball is traveling 58 feet per second at the 3-second mark. It's going up, it's right here. At that point it's going up by 48. When's the derivative less than 0? Well, between 7 and 14. Not including 7, but including 14, that's when it's moving down. All of these values, the derivative is negative. Well, that happens right here. All of these values, the derivative is negative. Find and interpret the rate of change. Well, this is nothing more than slope. This is an algebra problem. What's the rate of change from 3 to 7? Well, here's day 3. Here's day 7. What's that rate of change? Well, 294 minus 198. It went up 97. 7 minus 3 is 4. Let's see here. I think I had that wrong. Let's try that again. 294 minus 198. Yeah, it's 96. Which makes it 24 exactly. So the ball is rising 24 feet every second between the seconds of 3 and 7. 96 feet in total. but over a period of 4 seconds, it's 24 feet each second. I think we should say it's 24 feet. It's raising 24 feet between seconds 3 and 4. Alright, and the last one, acceleration. Sorry, 3 and 7. Find and interpret h double prime of 12. Well, that's this point right here. Input 12, output negative 12. That means the acceleration of the ball is negative 12 feet per second squared. Now this unit's kind of tough to understand, so I'm going to follow it up with this statement. This means the velocity is decreasing, because it's going down, by 12 feet per second every second. Just think of this as a speedometer on a car. 84 miles, then 72, then 60, then 48, then 36. You're getting slower every second by 12. And that's what derivatives do. They tell us how the function right above it is changing. This tells us how the position is changing. This tells us how the velocity is changing. Alright, on the back, you have the same problem, different equation.